Hello. So far we completed iterations 1 through 4, and we have an actual game cycle that is taking place. So in this video we'll start with iteration 5. Iteration 5 deals with the statistics of the game, and then just as a reminder, we have some enhancements on the actual game, which are things that we need to do on iteration 3 and 4, but I wanted to finish the entire game functionalities first before going into enhancement, because there is no end to enhancements. You can always enhance. So let's finish the actual game first and then go back to the enhancement. So this will be iteration 5. So we start with the problem formulation, in which we define the scope. So what's the scope here is, so far the game is played. It determines if the user made a correct answer or not, but it does not calculate a score. So we need to calculate a score. That's the first thing. So a score per game, and when the game ends, we give the user that score. Then the second thing is to update and display statistics. What kind of statistics about the game? Well, it's up to you. In this one, I chose 4 because I wanted to show you different possibilities. So I chose the highest score ever. So since the game has been played, the lowest score, the most recent score, or current, and then how many games. How many games played. All right. So how are we going to test this? So we need to play with no correct answers. So the score should be 0. Then play with all correct. So the score should be 100. So remember, the score is calculated as the number of correct answers over how many attempts, multiplied by 100 to get a percentage. So the score is a percentage. This is a formula I came up with. You don't have to follow this. Calculate the score anywhere you want, but you need to come up with a formula that ensures there is a unique score per game. So once you determine that, then you need to apply it on all correct. Some is incorrect and some correct, and then maybe play with one correct. So that should give you a score of 33. Maybe 2 correct, which will give you a score of 66. So I have 4 test cases. Nothing correct, so it's 0. All correct, it's 100. 1 correct, 33, and 66. That's also, of course, based on maximum turns of 3. Then we need to do the statistics, and the statistics will be tested by display the statistics view. Display stats view and view all stats. All right, so now we move to step 2, the solution formulation. How are we going to do all of this? So we start with the model. So we need to model the score. So the score is a decimal number, or you can choose to use as a non-decimal number. It's up to you. Decimal number, and so I'm going to use the type float. And I have also the highest score, or the stats values, all of them. Actually, all of them, the highest score, lowest score, recent, and how many games, all these 3 are actually scores. This is the only one that's not a score, which means that all these are decimal numbers, and how many is the only one that's a non-decimal number. So highest score, lowest score, and the current score. All of these are decimal, so we'll use float. And the integer, the number of games played, this is an integer, so we'll use integer for that. Anything else we need to model? I don't think we need to model anything at this time for this. We know the calculations. We already have. Actually, we do need to have a number. While we display correct answer, we do not count. So we need to have a counter of correct answer. So this counter will be an integer, and it will start with 0, and every time the user gets a correct answer, we increment that counter. So that's another one that we need. In terms of the view, so we need to beef up the stats view. The main screen doesn't change. We need to display the score. We need to find a way to display to the user the score per game. And we can put that in the alert view at the end of the game. Right? We can use that to display the score. In fact, we calculate the score at the end of the game, as you will see in the controller in a minute. Then in the stats view, we need to display all the scores. So if you remember the markup, the stats view had a display here of each one of the 4 stats. You can use one label with 4 lines, or you can use 4 labels, one for each. It's up to you. I will use one label and show you how you can dynamically create text with 4 different lines and add them to the label. So that will be on the view. Last thing in the solution formulation is the controller, and there are multiple items here in the multiple events with multiple actions. In the check answer, I need to count number of correct answer. And in the play game, I need to, at end of game, I need to calculate and display the score. Then the big challenge here is how do we update the stats? This is the stats view. And this is our main screen. The score is calculated here. And which means the stats view doesn't know anything about it. Remember our discussion in module 2 that each screen is its own independent module, and the scope of any object or any memory location is where they are defined. So since this one is defined inside this controller, the other one cannot see it. In project 2, we use the segue as a bridge to create a property in the stats view and transition the variable to the stats view. We can do that, but the stats view will come to life only when we launch it, which means how is it going to save the data of the different statistics? So we need something else here. We need a third party, a place where we can save the data. So we take the score, so we're not going to use the segue to transmit the data. We take the score and put it in this third place. And then when the stats view is launched, it come here to do retrieve. So this will be like saving the scores. This will come and retrieve the stats and display it. So the stats view doesn't know about the main screen. It knows about this third place and come retrieve the scores and display it. And it is the job of the main screen that after each game to update the scores in here. You calculate only one score, but based on that score you can update the highest, the lowest, and the most recent, and you can also always increment the number of games that are played. So what is this third entity that both of them will have access to it? There is multiple levels for that. You can use memory you can use memory, and there is a common object that all apps and the screens has access to it, called the NSUserDefaults. Uh, this is an object that can retain something like a dictionary, where you can put a name and a value, and you can add multiple names and values in that. But it stays in memory as long as you do not turn off your device. The data you have here will be available. Once you turn off the device, the data will be flushed. So it is good. You can use the NSUserDefault, but it's not as permanent. The second level would be to save in a file on the file system. So in the file system, this is your own the device file system, and you can put the stuff in a file, maybe a text file or extensible markup language file or any other type of file, and then retrieve it. This means it's on the device. When you turn off the device and turn it back on, it's in the device, permanent to storage, not the memory. The other level is the network file system. You can also, there's something here on the device also called database, or the network file system, which is could be a file or database, but not on the device, it's on the network. So you need the network to log in. For instance, iCloud, you can use iCloud to save that, especially if you want the content of that file to be accessible from other devices as well. This is a beginner class, so I'm just gonna stay at this level for this project. We might in the next project explore the file system, and in the advanced class we will explore the database and the network file system. So that's on the controller. Actually, more with the controller as well is that so in the controller we set the play game, what we're gonna do there, and then we need to update the stats. So we need an event or a function to update the stats. So at the end of the game, the score is calculated, the stats is updated. So we'll add a function called update stats that will retrieve the stats from the defaults object and then update it based on the current game. And then when the user launches the stats screen, so in the view did load on the stats screen, we need to retrieve the stats and assemble the label. So we need to add a label in the stats screen. I don't think I mentioned that in the view. Oh, I did. So we will update the label, and we'll do that in the viewDidLoad event. So finally, for this iteration, the solution implementation will say that first we need to, in the stats screen, we need to add. Actually, I'm gonna start with the play game. We'll start with the in the class add the correct answer counter. Then in the check answer, update or increment the counter. And in the play game, calculate and display the score. as well as update the stats. Then in the update the stats, we'll retrieve all the stats, update, and then save. Then finally in the stats screen, we'll add the label, make it 4 lines. Then in view did load, we'll update, we'll retrieve, create the text, the message, and then set the label to the message. Alright, so I took too long here, and this video will become too long if I implemented this now. So I'm gonna stop here and make another video for the implementation.